R&D. So within China, they've had over 300 projects, and in the rest of the world, 60 projects. And if you take into account the total installed capacity, then the reduction in CO2 emission by replacing grid power amounts to about 19 million tons a year. So a substantial contribution to greening the industry.
There are three main points where we can explore and utilize the waste heat. The first point is the preheater side. The second point is the cooler point. The third point is the kiln shell. From the preheater side, the gas temperature is from 250 and 420. The waste heat recovery capacity is closely related to the cement line's capacity. For example, if the cement line TBD is below 2,500 TBD, the waste heat recovery power generation will be lower than 3 megawatts. If the cement plant capacity is 3,000, the power generation could reach 4.5. If it is 5,000 TBD, the power generation could reach 9 megawatts. Okay, let's find out what kind of cement plants shall be equipped with the waste heat recovery power plants. According to our experience, if the power cost is higher than $65 per megawatt per hour, and the heat consumption of the clinker production line is higher than 640 kilocalories per kilo clinker, we think the cement plants should be equipped with the waste heat recovery power plants because it will bring the plants commercial benefits. And waste heat recovery technology can help save the CO2 emissions, especially in the developed countries like Europe, America areas. The ETS CO2 allowance is high. This can also bring some gains for the plants. We can see in the system, mainly 2 heat exchangers. One is cooler side boiler. We call it AQC boiler, air quenching cooler boiler. And the other is the preheater boiler. We call it the PH boiler. For the AQC boiler, normally we will take some piping from the middle section of the boiler, of the cooler, and then the gas will enter into the boiler and go up and go out from the top of the boiler, and then combined with this duct before the ESP or back filter. If you remembered in the slide, we showed that the waste gas will enter in the boiler from the bottom, and then the gas will turn the direction, goes up to this boiler. This is the direction change of the waste gas. And in the bottom part, integrated deuster device has been set up there. And there are a lot of baffle plates. You know, when the waste gas turning the direction, they will have conflicts with the baffle plates. So the big particles will drop down to the ash hopper. So this is a mechanical, or we can call it a gravity method to remove the big particles of the dust. The small ones, small particles, it will not block the tubes. So it will go together with the gas into the boiler and involved in the heat exchanging. As you know, the small particles of ash, they also contains some waste heat. So this is an additional waste heat when heat exchanging happens inside the boiler. This is